Saturn is the second largest planet in the solar system, located 6 planets from the Sun. It is renowned for its magnificent rings, which are composed of numerous ice and rock particles. Astronomers have long found Saturn fascinating, and numerous missions have been launched to investigate it. But the issue still stands. Is the trip to Saturn really that challenging? Stay till the end to find out. About 1.4 billion kilometers, 886 million miles, separate Saturn from Earth. Depending on where the 2 planets are in their individual orbits, the distance between Earth and Saturn fluctuates. Earth and Saturn are roughly 1.2 billion kilometers, 746 million miles away at their closest approach, while they are 1.7 billion kilometers, 1 billion miles apart at their farthest. The distance and duration of the trip to Saturn present substantial difficulties. The trajectory and speed of the spacecraft determine how long it will take to reach Saturn. For instance, the 1997 launched Cassini-Huygens mission took nearly 7 years to get to Saturn. This mission did, however, do several gravity assist maneuvers around other planets, which helped to speed up the journey. One of the most significant challenges associated with the journey to Saturn is the number of resources required. A mission to Saturn requires a large spacecraft carrying enough fuel, food, and water for the crew. The spacecraft must also have advanced life support systems to maintain the crew's health and well-being during the journey. The cost of building and launching such a mission would be high, making it an expensive endeavor. It's not simple to guide a spaceship to Saturn. To get there, the spacecraft needs to follow a specific path. Any departure from the intended course might result in the spacecraft missing Saturn or possibly colliding with it. In order to reach the planned time and location, the spacecraft must be able to modify its course along the way. Getting in touch with the spaceship is another difficulty. There is a sizable communication lag due to the separation between Earth and Saturn. Saturn is reached by signals from Earth in around 80 minutes. It is challenging to control the spacecraft in real time due to this latency. Additionally, the spaceship must be capable of long-term autonomous operation without human input. Spacecraft navigation and communication systems have advanced significantly to meet these problems. The Deep Space Network, DSN of NASA, is a global network of radio telescopes that can connect with spacecraft in the distant solar system. Engineers can keep track of the spacecraft's health and, if necessary, change its trajectory thanks to the DSN's two-way communication capabilities with the spacecraft. The first human spaceflight took place in 1961, and since then, space travel technology has advanced significantly. But when it comes to traveling to Saturn, current technology still has some serious drawbacks. The speed of spacecraft is one of the major constraints. The NASA Parker Solar Probe, which is anticipated to reach up to 430,000 miles per hour, is currently the fastest spacecraft to launch, 700,000 kilometers per hour. A trip to Saturn would still take a number of years at the current speed. Scientists are looking into cutting-edge propulsion technologies, like nuclear-powered engines or antimatter engines, to speed up the travel. These advancements have the potential to speed up trip times and increase the likelihood of visiting Saturn. However, these technologies are still in the experimental stage and have not yet been tested in space. The capacity of the spaceship to resist the harsh conditions of space is another technological barrier. Extreme temperatures, radiation, and micrometeoroids are all environmental factors that might harm a spacecraft's systems. Spacecraft must be built to survive these harsh environments in order to reduce the hazards. For instance, the Cassini-Huygens spacecraft had a radiation shield to buffer the radiation from its delicate electronics. Remote investigation of Saturn and its moons is now possible because of the technological breakthroughs. From 2004 to 2017, the Cassini-Huygens mission investigated Saturn and its moons. It was outfitted with a variety of scientific tools that made it possible for researchers to thoroughly examine Saturn's atmosphere, its rings, and its moons. The mission provided new insights into the complex system of Saturn and its moons, including the discovery of geysers on Saturn's moon, Enceladus. When preparing for a trip to Saturn, it is crucial to scrutinize life support and crew safety. A trip to Saturn would require a spaceship capable of supporting human life for several years, in contrast to earlier human space missions, which normally last only a few days or weeks. The requirement for a closed-loop life support system is one of the major difficulties in maintaining human life in space. The crew must have access to food, water, oxygen, and a mechanism that can recycle waste. This entails purifying water, cultivating food in a controlled environment, and eliminating carbon dioxide from the spacecraft's atmosphere. Creating a trustworthy and effective existence support system that can operate for several years is a significant technical challenge. Safety of the crew is another important issue. A trip to Saturn would subject the crew to prolonged radiation exposure, which raises the risk of cancer and other health issues. Also, because of Saturn's powerful magnetic field, spaceship systems may malfunction and put the crew at risk. The crew would also require protection from prolonged space travel's physical and psychological side effects, such as muscle and bone loss and social isolation. There are numerous measures that can be used to reduce these hazards. For instance, radiation shielding might be incorporated into the spacecraft's construction to safeguard the crew from dangerous radiation. Although astronauts must be emotionally and physically prepared for the challenges of long-duration spaceflight, crew selection and training would also be essential components in guaranteeing crew safety. Moreover, constant contact with Earth would be required to maintain the crew's connection to the rest of mankind and to offer psychological assistance. Planning a trip to Saturn requires careful consideration of life support and crew safety. To achieve a safe and successful journey, it will be necessary to solve enormous technical and logistical hurdles, such as developing a closed-loop life support system and reducing the dangers of long-duration spaceflight. In spite of these difficulties, investigating Saturn and its moons could have valuable implications for future space exploration. A trip to Saturn is a big task, yet it could potentially have several advantages, such as discovering Saturn's moons. Saturn is known to have 82 moons, and several of them are thought to be covered in oceans of liquid water beneath their frozen exteriors. It might be possible to study these moons and look for indications of life by traveling to Saturn. Technological advancement. A trip to Saturn would necessitate cutting-edge technology and innovation, which might result in improvements to life support systems, propulsion systems, and spaceship architecture. Improved knowledge of our solar system. A trip to Saturn would give us important new information about how our solar system formed and developed. Saturn's rings and moons provide clues about the early history of our solar system and the processes that shaped it. Progress in human space exploration. A trip to Saturn would mark a significant turning point in human space exploration, opening the door for later missions to investigate additional planets and moons in our solar system, motivating the next generation. People have always been motivated to dream large and work in the fields of science, technology, engineering, and math by space exploration, STEM. A trip to Saturn may motivate the upcoming generation of scientists, engineers, and explorers. Visiting Saturn is not an easy task, but it might have a lot of advantages. A trip to Saturn might have a number of advantages, including the exploration of Saturn's moons, the development of technology, and human exploration. While it may be many years before a journey to Saturn becomes a reality, the possibility of exploring this fascinating planet is sure to inspire generations to come. A trip to Saturn is difficult and calls for cutting-edge equipment and resources. A trip to Saturn would be extremely challenging due to the length of time and distance involved, as well as navigational and communication issues. Future technological developments could make a trip to Saturn more doable, such as improved propulsion systems and spacecraft architecture. Significant obstacles also exist in maintaining crew safety and life support systems. To meet these problems, NASA has created cutting-edge radiation shielding and life support systems. Notwithstanding these difficulties, a trip to Saturn is still an intriguing option that might aid in our understanding of the enigmas of our solar system. If you have reached this far, like this video, subscribe to our channel, and press the notification bell so you may not miss any future updates. See you in another video. Until then, take care. Do tell us your views in the comment section.